Are we good? Are we live?
Yes.
Okay. Well, I'm going to share my screen now. I was on the other side for a while. Well, good morning, good afternoon, good evening, whatever time zone you are in. Welcome to our webinar. It's been about a couple of months since we had the last one. June, we escaped because we had a big Data Plus AI Summit. So we thought that we would actually do a quick roundup of a couple of releases we actually have done over the last 2 months. And the MLflow team has been working excitedly to do a number of new features to increase your developer experience. My name is Jules Damji, and I'm going to be your host today. And along with me is joining me from San Francisco, Yuki, along with Tomu, who's all the way from Japan, and Joshua, who is based in Singapore. And then we have Carly in the background, who is actually bringing us this live to YouTube, LinkedIn, and X. So if you are hailing from any parts of the world, if you're joining us live, do please pop in and say hello and tell us where you're hailing from. This is a global community, and we do want to hear from people joining from everywhere, so that way we have an idea of who's joining where, so that would be actually nice of you. So here's what our agenda today. At the Data Plus AI Summit, we actually introduced a new framework, which I call the mother of meta harness, called Omnigent. And since then, we are at the release of 0.7. And this is a meta harness that allows you to orchestrate all the other harnesses that you actually use. And each of them might actually have some coding agents that actually work. But when you are running coding agents, you want to know whether the coding agent is doing the right thing. How do you actually find traces for them? How do you actually monitor? How do you evaluate that? So we'll actually hear from how Omnigent has been integrated with MLflow from Tomu, who has been one of the engineers who have been working effectively with that. And then the next two presentations are going to be by Yuki. And as I said earlier, we focus at MLflow, especially the open source team, very much on making sure that the developer experience is good, the evaluation experience is good. And so we try to cut as many pepper cuts as possible and to make the on-ramping and getting started and evaluating and looking at your traces very easily and effectively. And one of the features called Review Queue gives you the ability to include your subject matter experts to tag certain traces to review that. And so those two presentations, UVX setup and Review Queue, are meant towards making sure that your developer experience is good. And then finally, as I say, we keep on increasing our MLflow assistant, which is the ability for you to find root cause analysis and then other improvements. And Joshua is going to give us a rundown on that with a little bit of demo of what MLflow assistant is and what are some of the improvements that have come since we first released earlier, about a couple of releases ago. A couple of upcoming events which are related to the MI AI observability. If you're working with MLflow, evaluation and observability is a big thing. We have two in-person conferences, or in-person meetups rather, in the San Francisco Bay Area. If you are in the Bay Area, if you are living in San Francisco or just in general in the proximity, one is on the 8th of August, coming up pretty soon in a couple of weeks. Do take that particular QR code, scan it, and attend if you are. And then the other one is a marquee event, which is like a half a day, half an afternoon event. We will have 2 tracks on San Francisco. So those are the actually upcoming events as well. These are not going to be virtual. These are going to be in person. So you have to be in the Bay Area to be able to attend that. And if you're here, I urge you that you do attend them, because I think you'll actually get a lot of good learning. And it's a good way to meet the community. And then finally, if you're abroad, we have this very related hands-on technical meetups and workshops. I wouldn't say workshops, these are technical meetups based all around the world. And you can actually register them if you are living in any one of the cities that actually show on the roadmap. We're starting on the 25th in Montreal, and we're going all the way to December 9th on Sydney. If you're in Singapore, we actually have one in Singapore. We have one in Mumbai, and we have one in Sao Paulo if you're actually from South America. So those are actually good events to get to know about some of the Databricks products, as well as meeting the community we're actually working on that. And as I said earlier, we are very much interested in growing the community, and we enjoy and appreciate and really amplify your participation. And there are more than one ways you can actually be part of the community. One is joining our Slack channel, as you can actually see that. GitHub is actually a great way for you to file issues, to file PR. We welcome all the PRs, whether it could be a small PR, such as documentation, or it could be a first issue, or it could be any one of the things that you're actually interested to improve, what you actually have experience, and you want to actually make it better. So we welcome that. Join us on Luma, where we actually announce all of our local and virtual meetups related to MLflow. And we continuously post a lot of good blogs and a lot of good material, both on our X channel as well as on the LinkedIn. So do follow us to get up-to-date information about everything related to AI observability, about evaluation, about MLflow's Gen AI platform. And I think with that, I'm going to hand it over to Tomo, who's going to tell us all about how you work with MLflow and Omnigent. Tomo, take it away.
Yeah, sure. Hi everyone, I'm Tom Hieta. I'm one of the maintainers of MLflow, and recently I'm also a maintainer of Omnigent. So today I'm gonna talk about, first of all, like a overall like concept and features of Omnigent, and also talk about how to trace Omnigent with MLflow. So let's get started. Yeah, let's start from this question. What is Omnigent? So Omnigent is a meta harness rather than like coding agent or specific harness. Um, it its main feature is composition of different harness and agent, and also it provides a security and cost control for agent, and it allows a collaboration, like a multi-person collaboration for the agent session. It's basically allow you to Omnigent provide like a two type of harnesses. One is custom agent, where you can configure the MCP or system prompt and all the spec of agent. This is useful for both for coding, coding use case, and also for the internal like customized agent use case as well. We also provide a native agent, where we like a naturally wrap the various terminal coding agents such as Cloud Code or Codex or OpenHunt, and like give a seamless experience of coding agent, but also provides a native and unique functionality of Omnigent. Then the problem that Omnigent is tackling is nowadays it's a lot of like different companies and organizations are providing their own harness implementation, and also different enterprise companies implement their own custom agent as well. So here are some of the examples, not exhaustive. There's Cloud Code, Codex, Anti-Gravity, Cursor, Goose, and so on. So this is great. You have a lot of options, but there's also a downside of having so many coding agent and agent implementations. So Omnigent is developed to provide like a standard way to interact with like a various coding agent or custom agent in a seamless way and in a collaborative way. So the main architecture of Omnigent is like this. There's like an Omnigent server, and also there's an Omnigent runner. Omnigent server manages the composition history and also provides policies for security, and also also provide a common UI for you to interact with various coding agent and custom agent. We also have a concept of runner. Runner manages manages each coding and the custom agent sessions. So it provides a standard interface for various coding agent, and it also provides a sandboxing, so that you can use coding agent securely without typing a lot of yes for your permission request. So Lana provides a common APIs for coding agent and custom agent, and our our Omnigent server can be connected to various devices, including terminal, web, native application, and the mobile, and also you can interact with REST API. Yeah, one of the unique feature, as I mentioned, is Omnigent custom agent. So this is like an example YAML configuration for custom agent. You can configure the harness that you want to use. You can also configure the model that you want to use. You can customize the system prompt. You can also provide a tool so that your custom agent can perform what you want it to work. And also, it's not in this spec, but you can also enable the OS level sandbox so that you can protect your secret files from the agent and protect your confidential information from the prompt injection. We also provide a collaboration feature. So unlike most of the coding agent tools, you can actually share your session with your team member and with your friend. So this is useful when you want to share your coding agent session, when you investigate some bug of your system, and if you want to share your coding agent session with your team member, that's possible if you use Omnigent. Also, if you want to do that like a pair programming session, including agent with your team member, it's also possible with Omnigent. There's like a 2 level of permissions: read permission and edit permission. If you just want to share the session with your team member, you can just give a read permission, but you can also give a edit permission so that you can do the pair programming. Omnigent has a unique feature called contextual policy, which is for setting a context-aware like a security guard for tool goaling and turn initialization. So why this is called context policy? It's because traditionally all the policy policy configuration of Cloud Code or Codex or any other tools are just like a one-time setup. So you can just decide which tool can be executed. It's a static rule, but this static rule has a strong limitation that you sometimes want to allow a specific tool for the normal use case, but you might want to disable the specific tool when some event happens. For example, you usually allow your agent to use like a Slack or a Google Docs for the normal use case, but once your agent checks the confidential information through your enterprise system, then you want to disallow the usage of Slack or messaging tools. So with a static policy tools that we had in the previous coding agent, we couldn't do that. But with Omnigent, this policy is contextual, so it understands the session history. So you can define like a dynamic policy like that. This is one of the example. As I said, for normal use cases, you always allow the email usage of agent, but once it checks sensitive customer data, including PII, you disallow the usage of email, something like this. Then there's still a problem with Omnigent. Omnigent is, in my opinion, a great tool for enabling the multi-harness collaboration, but at the same time, it's with Omnigent, you could spin up 10s or 20 of sub-agent session in the simultaneously. Then it's getting more difficult to understand what your agent is doing. I think traditionally you introduce a tracing for Cloud Code or Codex. Then at that time, we our problem was we wanted to provide the observability for coding agent, because coding agent itself is a black box. But what Omnigent basically make it worse, because it's a multi-harness. So it's another layer of the black box. So this is a problem we wanted to solve. Oh, I think the color is a bit weird, but yeah, basically with Omnigent, with MLflow integrated with Omnigent, you can trace input and output and execution of your agent, so you can know, what kind of like input you set to your agent, and also what kind of output you get from the agent, and also you can see the trajectory of tool calling of your agent as well. You can start. Omniscient is auto compatible, so we use auto API of ML4 to enable this tracing. You can check our documentations to see what kind of configuration you need to enable the ML4 tracing for Omniscient. That's all for my presentation. Thank you so much.
Oh, Jules, I think you are muted.
Thank you. I should be knowing this very well. Well, thank you, Tomo, for a wonderful introduction about Omnigent and how it integrates with MLflow. We'll have some questions coming in towards you for the end, so I'll reserve that towards the end. Now, I'm really dying into here. How easy can you actually make the setup for agent? Yuki, tell us all about it. I tried it, and I kind of like, but I'm going to reserve my judgment. So you can tell us all about it. So go for it.
Sure. Thank you for the introduction. I'm Yuki. I'm a tech lead in the OSS MLflow team right now, and also work as a maintainer. So in this session, I'm going to talk about how to set up MLflow for your agent and how we trying to make it easy. So back then, let's remind like what we are doing in 2023 as an engineer. Whenever I want to learn a new tool, the thing I would do is I go to the GitHub or documentation and read a guide in the doc, and then maybe spend like 5 or 10 minutes to like click around and also run some command, run examples, and of course running through all those things takes like maybe 30 minutes or hour, but I'm happy because this is how it works. And of course, MLflow is also same, like pip install, then starting a server, and with the doc, there's a lot of quick start guides, and make your change to your agent code so that tracing is our first step. So we encourage you to like, hey, quick start. Let's start with tracing. And then once your code is instrumented, you can run the agent, and you will go to MLflow UI and look at trace. This is a kind of happy path, and we believe this can be completed in like 10 or 15 minutes, and we were probably okay with this in 2023 or 4. However, in 2026, at least for me, I'm not very satisfied with this kind of setup, because whenever I run 3 or 4 commands in terminal, or whenever I need to write more than 10 lines of Python code, I probably just go to coding agent today. I feel it's just too much for me to open the IDE and start typing or copy and paste copy and paste code and debug issues, or all doing by my hand. So basically, coding agent, I think, made us lazy, and we will probably be more and more lazy in coming years. So we want to change the setup to adjust to that new normal. And here is a new command. So you still need to install MLflow, but all the setup described in the previous slide is now in this one single MLflow agent setup. And in the under the hood, what it does is it actually uses coding agent installed in your terminal. It can be called closed code, it can be codex, it can be open code. You can choose whichever you want, and it use it to do the step for you with a specific interaction for MLflow, and also install MLflow skills to interact with MLflow tracking server. So once you run this command, what happens is it first installs skills, and it MLflow server startup, and it start up your coding agent, Claude or Codex Open Code. And then MLflow injects a prompt to say what actually you need to do to set up MLflow. For example, trace your agent, setting up some experiment or tracking server URI, everything happening within coding agent. So what you can do is just run this command, and wait for maybe a couple minutes, still 3 or 5 minutes, because there's still multiple steps to do. But you don't need to click around by yourself. You probably just go and grab a coffee, and when you come back, your MLflow setup is ready, and if you go to UI, the trace is there. And what enabled this single setup is skills. I think a lot of people already knows about skills and already have a lot of skills in your coding agent, and MLflow has one too. So we published a skill that includes a lot of different guide for operating with MLflow and a lot of best practices, so that coding agent can learn about like MLOps and what it has to do with when working on agent. Because there's a lot of different things when you work on agent compared to when you work on software. Coding agent is pretty good at software, but still premature for making change to agent. So MLflow skill is trying to kind of compensate that. The first thing is instrument, basically tracing. So in order to work with agent, you actually need to know what the agent actually does under the hood. So start with instrumentation. It has the skills to find evidence from traces, how to trace and how to look at trace, how to search for such traces from server, and diagnose, how to analyze the actual data within trace, and also how to measure changes. For example, token counts, latencies. There's a lot of important signal within trace. So the skill query MLflow metrics skill tells coding agent how to make use of all of the metrics. And finally, evaluate. This is very important. Once your coding agent makes a fix, you want to let it verify the changes, right? So MLflow provides a lot of building blocks, APIs, and like scholars, LM judges. So this skill include how to use those building blocks with coding agent. So once you install ML skills, coding agent now becomes MLflow Pro. And before skills, this is how it looks like when you work with coding agent to work on your agent. It's a bit meta because you're inserted coding agent layer. But anyway, so let's say you have some chatbot and you find a problem. For example, my chatbot doesn't know about my company's return policy. And you probably go to coding agent and tell, hey, can you update this agent to handle return policy correctly? What very likely happen is coding agent just say, okay, I got it. It's very tempting to say yes, because this is like how it is kind of not trained, but they're tuned for human preference. So it just jump into a solution. Then it's very likely to tweak system prompt, because that's the easiest fix. So if the issue is about return policy, coding agent just add a return policy text into system prompt, or maybe like just a 1 or 2 sentence of, hey, you must answer about return policy based on this XYZ. And then it's done, it commit a change and probably publish a PO, we reviewed it, and that it. Like there's no test, there's no check, or there's no other exploration. And it's someday it's for sure break some different question, because if you add a system prompt more and more, it just breaks some other instruction. So this is how it looks like if you install MLflow skills with that setup command. Now the skill tells MLflow not to jump into solution. First, extract the trace to see actually what is the problem, the root cause. So basically find the foundational issue, not only the like surface level information. So instead of saying like, hey, yes, sir, it just it start with root causing. And then it plans the plan step, which is clarify the desired behavior and plan how to verify it. So before implementing that, it actually think about the goal first. And then implement the change. This part is same, but after that, coding agent verifies the fix using the test case written with MLflow's evaluation API. So if you start, and setting up these things, it takes a lot of time if you are doing manually, but if you start with MLflow agent setup command, this is already there. So if you just tell coding agent, hey, please fix this issue, coding agent automatically does all of these steps. And what you need to do is just probably review the output of coding agent, which is actually about the second session. And yes, after all of these 4 steps, your fix is now, so your coding agent now file a PL, but as well as that, in addition to that, we actually have a test suite, right? So every fix now have a test. So it accumulates over time. And what you have is a very comprehensive test suite for your agent to prevent regression. You can run it on CI/CD. And nice thing is it's actually PyTest native. So in MLflow 3.14, we made the MLflow evaluate API fully PyTest native as well. So you can use that within PyTest just like your other system test, and the result you can track the result using MLflow run and see if there's any regression or not in your CI/CD. So yeah, this is a basic gist of the MLflow agent setup. So essentially, you can get all of this after running this command. So I highly recommend running this command whenever. Regardless of you have already MLflow installed or not. If you are new to MLflow, of course, please start with that. Even if you are using MLflow, I guess there's a lot of different features or skills you probably don't know yet. So this command gives you the full-fledged MLflow build coding agent. So please run this command and also tell us your feedback. All right. Can I just go straight to the next session, or maybe Jules, do you want to give some comment?
No, I think you can. One of the things I just put on the chat is the GitHub URL where these particular skills are defined, so people actually want to look at it. So it's under MLflow GitHub. If you actually go to the MLflow GitHub, you will see a sub-project called skills, and I put that in the chat, so you should be able to see that. But it actually has a good set of skills that you can actually use. Yeah, there you go. It's right there, MLflow skills. So take a look at it and give us a feedback, file an issue. This is a good, really starting step to get started early. So thanks, Yuki. Yeah, let's go ahead and talk about queues. This is actually a good feature that has been added in 2014. Or was it 2015, I believe? No, 14, right?
Yep, this is from 14.
Yep. Okay, all right, go for it.
Cool. Yep. So now we talk about how we make AI do job for our work, but the problem is it doesn't replace us. Even if we automate a lot of things, for example, fixes is now done by coding agent. Maybe even the setup tracing is done by coding agent. Maybe we look at dashboard is also done by coding agent. Building test is also coding agent. But we still need to be in the loop because coding is still, we are the one who know the domain most, and we are the one who care about quality. And there's a lot of different ways humans are actually involved in the loop. First of all, the discover failure patterns. It's more like free-form exploration. You have the agent and you first run it, then your next job is find out what's actually wrong. At the moment, we don't have a lot of clear view about the evals or even test. It's just we want to find out first what's actually good and what's actually bad. This is also called open coding, but this is the kind of first step we are involved in the step. And also once you get, you start to make some changes and implement fixes, you also need to verify those fixes by manual as well. We talked about the test, but the test is not always perfect. So at least from the first few steps, you still need to look at it manually, and also in case if there's anything unexpected happens, you want to maybe pause a release of that fix. And the last thing is annotation. So some type of eval requires ground truth, like correctness or tool call correctness. There's a lot of different metrics or criteria we can only use with ground truth, and that ground truth need to come from human. Of course, there's a way to synthesize that, but the best way to get the ground truth is actually a human. And right now in MLflow, before 3.14, we can kind of do that. MLflow support human feedback, but the flow was not very smooth. So we want to solve the problem, and we introduced the review queue feature in 3.14. This is like an inbox. So you have traces in your experiment, and you can send your traces to this inbox review queue to track the human review process And maybe it can be a different person, different domain expert or PM or stakeholders. So what we want to do by developer is just like assign all these traces and to send it to those like domain experts. So, okay, sorry, there's like some order mismatch, but so as an assigner, like as a developer, what we need to do is select traces in this trace list and click on this action button, which shows like flag for review. And we can configure a few queues. Each queue is an inbox, and each queue has a list of questions. So what we want to ask for those reviewers, for example, ground truth, like expected answers, or maybe free-form feedback, or maybe just a Boolean, like pass or fail for particular feedback criteria. So we can configure all of these like questions for each queue. And what we need to do is just send the item to the queue. And from reviewer side, what happens is they open the page. So we can share the review queue link to them. They open the page and they will see this kind of forecast UI. This is very different from other part of MLflow. There's no table. There's no like a lot of setup. This is very focused. They only see the response and request and response for urgent and a few pre-configured questions we wanted to ask to the reviewers. So what they need to do is they don't need to learn MLflow. They don't need to open trace necessarily. They just answer questions on the right panel here for every trace in the inbox. So this is pretty easy for those like reviewers. And after all of this is answered, this inbox becomes green. And now we can, as a developer, we can use those feedbacks for the downstream task. What kind of downstream task we can do? There's I think of like three different use case for this like review feedback. Human feedback is very expensive, so we should really like make sure we take advantage of that. We get the full value from it. And there's three ways we can get value. First thing is these two problems. So if you only review 5 or 10 traces, maybe it's okay. You just look at all the review comments and say like, okay, so this is an issue we need to solve. This is not a big issue, and prioritize that. Maybe talk to them. But if you start to assign like 30, 50 or more traces to maybe multiple reviewers, it suddenly becomes bottleneck to review all of these feedbacks and prioritize issues. MLflow provides a feature for that, which is called issue detection. This is like automated job you can set up to extract those problems from traces and feedback attached to that trace. So what you need to do is you click on the traces from the review queue, basically all the traces completed reviews, and click on LLM configured here, automatically look at all those traces and extract a cluster of issues, just like a Jira board, right? So you can fix those issues, or maybe start doing eval for this one, or maybe ignore the ones that is not important. But you basically speed up the review process from looking at like 50 or 100 traces to just click on one button and wait for a few moments. Then after that, we have an issue, we can do maybe eval to verify the fix. And in order to do that, you probably want to have a data set of that issue, right? You want to probably group the examples together into nice like logical bundling. And MLflow provides a very convenient way to do that. You can just click on the traces again and select export to dataset. Then all the record and also ground truth recorded to the trace automatically populated into this dataset. So you can use it for evaluation API, or maybe your own like custom eval. But now you have a like group of very good example of like one issue cluster. Okay, so then speaking of the verification, of course you can build some LLM judge or maybe some custom scholar, but it's very important that the judge, that evaluation is actually aligned with human preference, right? Because if you just create some eval and run it and it says okay, but it's very possible that that okay is different from the okay from human experts. So since you already have a human expert feedback, like why not create LM judge that actually copies what the expert thinks. In order to do that, MLflow provides a judge alignment API, which is basically with the feedback score and traces, we have some optimizer, which is called MLalign, that automatically look at those traces and feedback and tune the prompt for LM judge. So first we need to define the LM judge, but from that like bespoke prompt, we run this align API, and after that, this align judge contains a much more like tuned prompt, and the result will match with the human expert. So we basically can scale the human feedback step to more and more traces, like multiple iteration during the fix, without asking them to review again and again. So yeah, this is basically a gist of a review queue. So in a nutshell, review queue is a kind of inbox you can assign trace review and let the reviewer annotate or give feedback in a focused view. It has a very nice view of tracking the status of the review. And once it is completed, you can distribute the problem from traces using issue detection. You can build the evaluation using the MLflow dataset. And you can also scale that human feedback loop using judge alignment, because that judge now can replace the human expert on that specific criteria. So yeah, review queue is available for in MLflow 3.14. So there's a doc as well. So if you are interested, please go to the doc and start annotating traces. Okay, yeah, that's it for the review queue part.
Thank you. I mean, this is quite an important feature. I do have a couple of questions, but we'll leave that towards the end. But yeah, certainly it's going to be something that's quite valuable if you're actually doing a critical user journey. So I was going to ask you, where does it actually fit into the critical journey? But we'll leave that towards the end for the discussion. Joshua, tell us all about what improvements we have done to ML Assistant since the last time we released that a couple of releases ago, where you could actually ask the ML Assistant to look at your traces and find root cause analysis. What's new now that people should be excited about this? Tell us all about it.
Sure. Thanks, Jobs. Hi, folks. I'm Joshua, and I help to maintain MLflow. So today, I'm just going to share like some updates about the MLflow assistant since we first launched it in 3.9. So just a quick recap for those of you who may not have used the system before. So this is the MLflow assistant. It's a LM-powered in-product copilot for debugging your Gen AI apps and agents. So the nice thing is the MLflow context is already baked in. So you can install the MLflow related skills that Yuki mentioned earlier. As Jules mentioned, it reads your traces, and you can even use it to like iterate on your local MLflow project. So it's definitely more than just like a simple chatbot. I think the first thing that we want to talk about is the first change that we made, rather, is greater provider support. So at launch, we targeted users who are using Claude Code. So back then, like Assistant ran in your local Claude Code. It gets access to all your local skills and configuration at zero additional cost. But we understand that everybody has preferred models, and sometimes you just want to change things around as well. So with the latest releases since 3.9, like we are supporting way more providers. For local development, you have a choice now between Claude, Codex, or local Ollama server, which have been added thanks to support from our community. So these local providers, they function just like Claude Code used to. They support our custom skills, and you get the same experience across the board. And not only users can test them with their MLflow gateway endpoints. So if you have already any like endpoints set up on your application, it's really just plug and play. And I'll show this later. And we support like many providers via gateway. So you can easily run Assistant with the model of your choice. Next up, we have a short video on like what the new features. So here I'm using like Claude Code and interacting with MLflow Assistant. So I'm just verifying that it is Claude Code and not somebody else. So let's just give it a while. And yes, it is Claude Code. So I'm going to try changing the models. I pre-registered like a model called Haiku, which runs Haiku 4.5. And I'm just going to clear the chat and let's just try something which is analyze the trace, which is something that MLflow system is pretty good at. So I'm just going to ask it to simply just summarize this trace. Okay, so it's running. There's some new UI here that we'll talk about later, but it's calling a few tool calls. And yeah, I think it works. This looks correct. It looks like a correct summary of this demo trace that I have. And yeah, this is the new like tool UI, which I will talk about later. But I think, yeah, next up after this, the nice thing about it being integrated with MLflow Gateway is that I get all the benefits of Gateway like tracing. So you see that this chat created 2 traces. So I'm going to look at one of them. And we have like the usual information, latency, cost, like token count. And yeah, it is summarized this trace, which is the message I sent earlier. So everything now gets registered as a MLflow trace. So it's quite easy to see how your assistant is functioning under the hood. And you get like perfect visibility in your assistant with like no additional hassle. I think the next big change we've made is around like setup. So in the past, you had to like set up assistant manually. So with 3.15, however, if you're running MLflow locally and you already have Claude or Codex installed, MLflow will auto-detect this when you're running locally and you can just hit the ground running. So just send a message and it should start pinging your local Claude code or Codex instantly. And we've also simplified the setup process. So in the past, you might see like a 3-step setup process, but right now, if you're using one of the popular like providers like Anthropic, OpenAI or Gemini, you can now perform the entire setup process from within the chat window. So like no context switching required. It will prompt you to put your API key and any keys that you add are automatically added to our secret store and shared throughout MLflow. So you can easily reuse it as well. The next change we want to do is like give additional visibility to Assistant. So you want to make Assistant more like the coding agents that you're familiar with. So some UI enhancements include like better visibility into what it's doing. So firstly, I'll start with tool calls on the left. So this was shown during the demo just now, but we have tool call views now. So one row per action the assistant takes. And you can watch each call as it runs. You can expand it. You can see what it queried, what came back, see the status. And if the assistant answer looks a bit off, like just scroll up the chat, you can see what ran and if there's anything unexpected in the tool call. So you can debug like anything going wrong quickly. And down in the text box, we have like token and cost control. So we know that like costs are becoming a big concern for everybody now. So you can now see like the model you're running. If cash tokens are available, we show it. So we want to make sure that cost isn't a surprise at the end. And if we get the information, we try to do like best effort cost estimates on like how much this like assistant chat is costing you. And lastly, for like users that do like local development, we've tried to make sure that you can do more of like MLflow assistant. And in the past, when you use assistant, we had sort of like 2 modes. One is called full access, which is kind of like dangerously allow all. And then we have restricted, which offers like a more restricted set of tools. But we understand that sometimes if you're developing using assistant on your machine, you might want to go with like restricted, but you kind of want to have a choice to like approve or deny things. So we've added features like the ability to approve like tool calls, for example, on restricted access mode if you're using like MLflow Gateway. So this hopefully gives you like more confidence to like do more of MLflow assistant locally and gives you a bit more flexibility. So we do have other like quality of life improvements on the UI. So please check it out and leave us any feedback. So that's Assistant so far. It's more configurable, it works out of the box, and it feels more like a coding agent. But as for what's next, we want to make Assistant to an even more powerful co-pilot. So for the previous releases, like Assistant was mostly a local-only feature because it ran like local coding agents. But we know that many of you host MLflow, and you want your team members to also have access to the assistant. So we are experimenting with more remote usage in the assistant. So this is enabled for assistants using the gateway, since gateway does not run locally. And this was kicked off by like just a shout out to our community like Supersonics for setting this up. So this feature is still like very experimental and very early stages, but we are definitely planning an experience here because we think that like better remote support is like the next logical step for improving like the utility of the MLflow assistant. And lastly, like I know that most of us are quite reliant on LLM to increase productivity, myself included. And we are looking at a deeper integration with like MLflow CLI, getting more tools into MLflow so that we can perform like more MLflow workflows from within the chat window in like natural language, which is simple and easy for everybody to use. So that's it from me. The assistant can be found in the bottom right corner in 350. So please check it out. Thank you.
Thank you, Joshua. That's a lot of golden nuggets you actually have. Could I actually have all the rest of the people on the panel so we can start unpacking all these golden nuggets that you guys have shared with us today? Yuki, Tomu, are you guys on? Brilliant. Thank you. Tomu, thank you. Let me see. I have one question that actually came in. A few people. Ravi, who's been our regular attendee, always has good questions, and he's asking, does the MLflow assistant work running in Omnigent? Does the MLflow assistant work running in Omnigent? I think there are going to be a lot of questions about related issues since we have opened up a very fruitful and a very good integration with Omnigent and MLflow. So what do you think, Tomu? What do you think, Joshua? Is there a possibility of Omnigent working in MLflow assistant?
Yeah,
I mean,
I think I'm just. Oh yeah, Joshua, please go ahead.
Oh no, like I'll just answer first. Like I think currently it doesn't work running Omnigent, but that's interesting. Yeah, I think it's definitely something we can explore. Like, sorry, Tomu, you were saying.
Yeah, correct. I think it doesn't work. Under the hood, I think both of them are using different harnesses. I think ML4 assistant supports Cloud Code, and do we support other agents as well?
Right? Yeah, Codex.
Yeah, Codex, right? Similar. I think Omnigent also use like Codex or Cloud Code under the hood, but they are different interface, so they are not integrated together. At least like now.
Yeah. I think this would be a good point of discussions. Something that I was thinking about that you mentioned, Tomu, with the slides about all the other harnesses that we have actually integrated with Omnigent, and we can somehow capture the traces. What about if I actually had a harness that I was using that was my custom agent? How would I be able to capture that? Because right now, if you're using Codex, or if you're using, Claude, we have integration already, right? Because we just, as a plugin, we just execute that command, and then now we're actually capturing we intercept those traces. How do we do that with custom agent? Would they actually have to instrument the custom agent to do that?
Yeah, so the like instrumentation part of Omnigent Tracing is a little bit different from the existing integration from MLflow to like other coding frameworks. So for the for tracing, like MLflow tracing for coding frameworks, agent frameworks is basically done by either the auto integration or basically patching some of the important methods of agent frameworks. So we have to integrate with each harness one by one, or each framework one by one. But for Omnigent, we instrument Omnigent on the runner layer rather than the harness layer. So once the harness is once the custom harness is integrated with Omnigent, it works. Yeah, it works naturally and automatically with MLflow tracing integration, because we always use runner for any harnesses.
I think a related question. I think I'm going completely hazy with my camera. Let me just try one more time. Well, I don't know. It's
I don't know. I can.
I'm quite clear on the YouTube, but I don't know what has actually happened. So the question is, as you pointed out, we have all these policies in Omnigent which are contextual in their scope, right? The policies are running in the runner, and they are intercepted in the runner. When we actually have a contextual policies such as allow, deny, approve, those are done at the session level. How would those policies action be captured by MLflow traces? Because MLflow traces is request based.
Yeah. So currently the MLflow tracing for Omnigent is kind of limited. It's more for the agent execution, not for the
Okay,
server-side event. So
Okay,
it doesn't
good,
capture policy,
good.
but it's a good enhancement.
Good. Yeah, I mean, I just want to make sure that people understood that note that the session based policies, which are contextual in nature, they sort of allow us to have more control over it, and they're request based policies that we actually that the traces actually capture along with all the other stuff. This is more of a philosophical question. I really liked what Yuki said in his said, coding agents have made us lazy. They've made us, so have they actually made us lazy, more productive, or they've just spoiled us? What do you think? I mean, it's debatable. So I just wanted to get your answer. I'm going to ask everyone, Wayne, what do you think the coding agent have actually done to our field of software engineering? Do you think we are being productive? Are we being lazy? Are we being spoiled? Or are we losing our skills?
Well, yeah, you can talk in an hour, but like
yes. We still have 10 minutes.
the best way is like lazy and productive, right? Like if you are lazy but still productive, that'd be great. So I think I believe coding is actually boosting our productivity, and well, of course, like, it's not linear. Like if we just like more code, it doesn't mean we are more productive in the same ratio. But of course, I can, for example, I have Omnigent in my phone, and I can do a coding while I'm like doing the gym, and that's, I think, productive still. Like I'm still lazy, but so yeah, usually overall I believe in that coding agent productivity thing, and think also a lot of different agent development steps we are doing right now should also take advantage of agent coding agent more. So that, I think, is the one thing we as MLflow we can trying to evangelize people, and we are trying to add a lot of more helpful features so that people can be more lazy during developing agents.
Yeah, I mean, I agree to a certain extent. To me, they've helped us become more productive, and I think Joshua pointed out all the good features that the ML assistant gives us the ability to do root cause analysis, to do remote execution, to be able to actually create data sets, and what you pointed out was how you can actually use the setup, the queue, to be able to actually look at all the evaluations. So yeah, to me, yes, they've actually made us lazy, but at the same time, they made us productive. I know lazy and productive is an oxymoron because they can't really be together. But overall, I think people would agree that it actually has changed our lives and has made us more productive. And as I said, this debate can actually go on forever, and I don't think there is an answer for that. Ravi pointed out, well, coding agents only make us only lazy if we allow them to do that. That's an interesting take on it. Right, because if you're just going to doing wipe coding, then you pretty much are being lazy if you don't understand what the code actually generates. Another question I actually had was for you, Yuki. You mentioned about the review queue have been very effective. Where do you think, in a typical or a critical or a common CUJ, the review queues come in? Do they actually come in during the time when you are prototyping it? Or do they actually come after the fact? Where do you think is most effective use of queues?
Yeah, that's a great question. Of course, there's a lot of different ways to use a view queue. It's very flexible abstraction. But the major use case we hear from our users or customers is actually, so whenever they interact with domain experts, right? So if you are just doing solo development, you probably don't need a review queue yet. But if you, during the development, you have a similar different point you actually want to collaborate with those experts. The first thing is once you prototype, you probably want to share this with them and get a feedback from them. So at that moment, the review queue is great to collect those free-form feedback. And once you get those feedback, you have an idea of, okay, what is good and what is bad. And you iterate on the prototype, and you actually start productionizing that. Then before going to production, you actually need to have that check again with maybe more fixed criteria, because comparing to the first step, you have more idea about what is the criteria of good and bad. So at that moment, you again collaborate with those experts, but with more fixed questions defined.
Yeah.
And lastly, you may want to do it in eval. So you can also ask it manually, but you want to convert it to eval to scale that. At that moment, you also want to collect the ground truth maybe. That is I think that's hard thing you can do with review queue. So yeah, and then once you go to production, you start getting a lot of more and more different unknown questions. So now it go back to the maybe prototype step, like, hey, from all the production traces, you probably want to sample a few of them and send it to review queue so that expert can read free-form feedback. Okay, actually in production conversation with users, this is a new problem we didn't know. So then we go back to the same loop. So that is, I think, is a kind of typical user journey in agent development, which we hear from users and also in the industry. So,
which fits in well with the whole paradigm of building reliable agents is a really function of doing evaluated driven development, right? So you're constantly evaluating, and part of the evaluation is you taking the queue and getting the feedback from the subject matter experts. Brilliant. Joshua, a question for you. You talked about the upcoming possible request was remote ML assistant. Can you explain what does that actually mean for a person who is doing everything on the laptop and now all of a sudden they have to use a remote ML assistant? Does that actually mean that they're interacting with it through an API and the runtime agent is running remotely as a service, or is it actually running locally? What's the difference between that?
Right. I think like with remote assistant, like if you're doing like local development MLflow, like nothing changes. Assistant is still running locally. But I think like the big win here that we see is for like if you're hosting MLflow on your own, for example, and in the current state, the MLflow doesn't support like assistant on like hosted MLflow for the previous versions. But I think for like a collaborative setting, let's say if you're hosting like MLflow and for a team to collaborate and like develop like agents, like just having like remote assistant setup will enable like your team to just query assistant in natural language. So it's more of like helping people to collaborate for like hosted MLflow. Nothing really changes if you're just doing local development. So it's more of a value add rather than just like a change for local users.
So right now, I mean, I looked at the config that we actually have added. So we actually have a list of all the extra coding agents that we actually do. So if you really want to use all those open source model, this is the sort of a new beneficial that you can actually use, because ML Assistant does cost a lot of tokens. I mean, I've used it. I've burned quite a bit of token when I was doing root cause analysis, and I looked at my bill, and for a sudden, in one evening, I had burned about $15 worth of token. I go, oh my goodness, what did I do, right? And so having the ability to actually use open code and then having the ability to use Llama running locally on the machine, it actually helps. The question is the quality of the root cause analysis between completely open source with the smaller models is way different from the reasoning models that you normally use by default.
Yeah,
right.
You raise a very good point. So, so first in the chat question, what local models we support? I think we support Llama and Gateway. So I think all the local model popular ones are available. In terms of questions, we actually building the like eval suite for assistant, and one of the benefit is we actually be able to systematically evaluate which model is suitable for assistant job, like analyze traces, because we sometimes maybe don't need like 5 for analyzing single trace. Can probably define like what is the like optimal setup. We can probably default assistant to cheaper one, and like trying to reduce the token usage and more aggressively with eval. So that is our North Star, and this is pretty much we are using MLflow to do that. And so hopefully along the way we also add a lot of features or fixing issues to make all users also can do the same journey with their agents.
And normally, I mean, the questions I get is okay, we can actually do root cause analysis using the ML assistant. Let's say I have 15,000 traces that I ran over it. Am I going to ask him to do root cause analysis in 15,000 traces? Or do you think we actually have a rule of thumb whereby saying do it in batches, because you can do it in batches? And so have we done any kind of analysis by saying if you have X amount of traces, here is a rule of thumb to do Y amount of batches and then run per batch every now and then to get some idea about it?
Yeah, if you have thousands or hundred traces, I do recommend starting from the issue detection job, which is actually designed to scale more.
Okay.
Yeah, and actually, eventually, we are also trying to integrate with this assistant. So ideally, we can just prompt assistant, hey, there's 1,000 traces, can you analyze that? Then instead of assistant look through one by one, they can use
Okay.
by themselves.
So by issue, you're talking about the button that we actually have on the top right-hand corner where it says issue detection, and then it gives up a pop-up that's saying, here are the configurations you actually want, the batch and all that. So that would be, all right, so whoever asked that question, this is the way to actually do that. I think we are a couple of minutes over time. I want to thank everybody who actually joined us today from different parts of the world. Thank you, Joshua. Thank you, Yuki. As always, you bring a lot of insights, and Tomo, as always, great features. So keep up the good work, and hope to see you in a couple of. Is there anything you want to add, Yuki, for the upcoming releases into that 3.16 that you want to share with the community? If not, they can always look at the roadmap. I think the last slide I have is about that. What's coming up in 3.16?
Yeah, I have a local version for that. So maybe I'm sharing the screen. So if you can actually switch back to the shared screen. That's, I think, the one from Joshua. Okay, yeah, here we go. Yeah, so for 3.16, which will be probably around the end of August, we will have a few different features. First thing is custom trace view. So we talked about reviewing traces, and the review view showing the request, response, and trace, which is minimal. Right? If you actually want to do more deep review, for example, for tool calls or for retrieval, the default view probably is not sufficient for you. So we will release a feature to customize that view and also integrate with the system as well, so you can define your own review surface that is optimal for your reviewers. And as usual, we are always like trying to improve the UI, but we will do like batch overhaul for trace and evaluation in the next couple runs. So to make every journey pleasant. And AI search is an interesting one. So now we have a lot of search box in MLflow. You can search runs, you can search traces, you can search data sets, but it requires like setting up filters and writing queries, which is sometimes not too straightforward. So we will integrate the assistant to also writing a search query for you. And Joshua just launched the one feature that you can save the search query, search filter as a view. This is already available in 3.15, so please check it out. But once the AI search is available, that will also integrate it. So you can basically define your own optimal view for MLflow using AI or maybe by your hands. And the last thing is, not sure if it is 11.16 or not. This is something we are actively working on, the skill registry. So a lot of people have skills, and a lot of people are also improving skill or editing skills. So we want, as MLflow, we also want to help that journey. So we will ship something called skill registry that allows us to manage and improve and basically manage and iterate on skills using the features like tracing or evaluate, just like your custom agent. So that will be another big rock we are shipping in the next month or so. So there's a lot of more features in the under building, and the roadmap thread is not up to date for some of this. So I'll make sure I'll update after this webinar. So please check it out in next week or so. Yeah.
Thank you, and give us a star if you actually haven't given us so far. So I think skill registry is going to be an interesting feature. A lot of people have been asking about it. It would be something very analogous to in terms of feature and functionality with prompt registry. So thank you all, and hope to see you in another 6 weeks.